All right, let's jump right into a couple of ideas that are honestly at the heart of so much math: squares and square roots. We're going to look at how you build numbers into these perfect squares, and then how you find their hidden roots. It's actually a really cool visual concept. So let's do this. Okay, so take a look at these numbers: 1, 4, 9, 16. At first glance, they might seem kind of random, right? But what if you think of them as dots? Suddenly, this really cool pattern starts to show up. There's something that connects all of them. Any ideas what it might be?
Yep, you got it. They all form perfect squares. And that's not just some happy accident, it's literally why we call them square numbers. It's a great little reminder of how visual math can really be.
Okay, so what's the actual definition here? Like, what's the math behind what makes a number a square number?
It's actually super simple. All you do is take a whole number, any whole number, like 7 or 10 or 20, and just multiply it by itself. That's it. The number you end up with, that's a square number. And you can see that right here. 1 times 1 is 1. 2 times 2 gives you 4. 3 times 3 gets you 9, and so on. See? These are the exact numbers from those dot patterns we saw a minute ago. It all connects.
Now, let's be honest. Writing out 7 times 7 or 15 times 15 all the time, it gets a little old. And mathematicians are all about finding a cleaner, faster way to do things.
So instead of writing the whole thing out, there's a shortcut. It's called squared notation, or sometimes index notation. It just makes everything look way cleaner and lets you see what's going on instantly.
So here's what it looks like. You write the number, that's your base, and then you pop a little 2 up and to the right. We read this out loud as 7 squared. And that name is perfect because it literally means 7 made into a square.
Okay, pay attention here because this is the #1 mistake people make when they're starting out. That little 2 does not mean multiply by 2. No. It means you multiply the main number by itself. So 3 squared is 3 times 3, which is 9. It is definitely not 3 times 2, which is 6. Big difference.
All right, so we've got the hang of building squares. But what if we want to go backwards? What if we start with the finished square and we need to figure out how long one of its sides was? Well, that's exactly what square roots are for. The textbook we're looking at says it perfectly. Squaring and finding the square root are inverse operations. It's just a fancy way of saying they're opposites. Like addition and subtraction or multiplication and division. One just undoes what the other one did.
So let's just recap real quick. Squaring, that's the building process. You start with a side length, let's say 5, you multiply it by itself, and boom, you get the area of the square, 25. And the square root, that's the unbuilding process. You start with that area, 25, and you ask yourself, okay, what number did I have to multiply by itself to get here? And the answer, of course, is 5.
And this right here, this is the official symbol for the square root. It's called a radical sign. Whenever you see this little guy, it's basically asking you a question. It's saying, hey, what number times itself gives you the number that's inside me?
Okay, so the theory is pretty straightforward, but it's always better to see it in action. So let's try a couple of examples. All right, here's one for you straight from the textbook. What is the square root of 196? So think about it. What number times itself equals 196? And the answer is 14, because 14 times 14 gets you exactly 196. So the square root of 196 is 14. Simple as that.
Okay, now here's a really important rule you got to remember. It's about the order you do things in. Think of that square root sign like a set of parentheses or brackets. You have to solve everything inside it first before you do anything else.
Let's take this problem, for example. The square root of 29 plus 35. So, step 1, you got to handle what's inside first. So, 29 plus 35, that's 64. Now we can deal with the square root. So what's the square root of 64? It's 8. And there's our final answer. It's 8. All right, now for what I think is the coolest part of all this. Square numbers have this secret property. It's something that most people just never even notice, and it makes them totally unique. And the secret isn't in the shape they make, it's hidden in their factors. All the numbers that can divide into them evenly? Just look at this comparison. Let's take a number that isn't a square, like 24. Its factors always come in these nice little pairs. 1 and 24, 2 and 12, 3 and 8. See? You always end up with an even number of factors.
But now look at 36, which is a square number. It has an odd number of factors. Weird, right? So what's going on?
Here's the really elegant reason why. For any square number, one of its factors doesn't have a partner, because it partners up with itself. For 36, the number 6 pairs with, well, 6. And since we only write each factor down once, that lone wolf factor makes the total count odd. This little trick works for every single square number out there. Pretty cool.
So we've kind of unlocked this cool little secret about square numbers. Which makes you wonder, doesn't it? What about cube numbers? You know, a number multiplied by itself 3 times. Do they have some kind of secret code of their own? That's a great question to chew on. Thanks so much for joining me.